So a tool that we use in probability to help us visualize statistics is something called a Venn diagram. Here's our first example. There's 100 students in grade 12. 38 of them do archery. 62 of them are injured. No, just kidding. So we draw a circle representing archery. We write the number 38 in there to say 38 students. We put a box around the whole thing to represent everybody. There's 62 people that aren't in archery. That is represented by the number 62 there. Some notation. If A is the represented for archery, then N of A, which is how many or what is the number in A, would be 38. The whole thing is U, so the number in U is 100. Can you see that U includes the 62 and the 38? So that's why the number is 100 and not 62. So then we use this for probability questions. If you choose a student at random, what is the probability that the student did archery? Well, that's 38 out of 100. But there's the notation. We take the number that are in archery over the total number to get our probability. The complement of an event A is denoted with an A with a dash, or sometimes you'll see it with an A with a line over top of it. And that's the probability that an event does not occur. It's the opposite of what you're looking for. Okay? In the example above, it is the area outside of set A. So if we wanted to write the probability of not being an A, there's 62 people that didn't take archery out of the 100, which is 62 out of 100. And this idea is sometimes really, really useful for figuring out questions. Does it make sense that the probability of A plus the probability of not A will always be 100%? I wonder, what are the chances that tomorrow it rains or it doesn't rain? 100%. And if you rearrange that formula, you can either get probability of not A is 1 minus probability of A, or you could get probability of A is 1 minus the probability of not A. And we'll use that strategy because sometimes a question will ask you, what's the probability of A? And it's really complicated to figure it out. But it's really easy to figure out the probability of not A. So if it's really easy to figure out the probability of not A, you can just do 1 minus that, and you'll be left with the probability of A. The intersection of events. The region where both events are true. In a Venn diagram, we could draw two circles representing two events, and sometimes there's people who are both. Okay? And what this symbol here, when we're reading it, we would read that symbol as and. In fact, I think of the symbol itself as very close to being an A if I had drawn a line across it. And that's how I remember that that means and. It has to be in A and it has to be in B. Right, we could ask in this class, right, some of you are taking IB physics. All of you are taking IB math. Right? You aren't all the IB students, but we could have a circle of IB math, and that would include all 18 of us. We could have a circle of IB physics. How many people are in the IB physics class in total, do you think? 8. And how many are in this class? All 8 are also in this class. There you go. So the intersection of them would be the 8. I could probably pick some other classes that there's some people in here, but not everybody. Like, is there anybody taking the IB biology? Yes. Is there more than 4 people in the IB biology class? Yes. Some of you aren't here. So the intersection would just be the 4 people. Suppose there's 100 students in a gym class, 38 do archery, 30 play badminton. Of those, 16 do both archery and badminton. So we draw a Venn diagram. This represents the 100 people. One event in there is A for archery, and another event is B for badminton. Now, when filling in the numbers here, 16 do both. So we will put a 16 in that intersection to represent those 16 that are doing both. Now, the temptation for students is to do this. This is going to be wrong, but you can see if you're tempted to do this. It says 30 play badminton. Someone's going to write 30 there. This is not correct, because right now, inside the green circle, what do our numbers add up to? 46. There's not 46 people that like badminton. So instead, this number in here can't be 30, because all of the green circle adds up to 30. And if all of the green circle adds up to 30, does it make sense that this would be 14? And if all of the blue circle adds up to 38, does it make sense that this is 22? How many people are outside of this? If we add things up, we're up to 52, right? How many people in total? There's 100 students. And so the Venn diagram lets us figure out these numbers easily. So now we can answer probability questions. Find the probability a student picked at random plays both archery and badminton. This is probability of A and B. Well, that we could have done that without our Venn diagram. If I add up these numbers inside the circles, this is 30, 52. Okay? Yeah. It doesn't add up to 68, even though we have 38 and 30, right? Because there's some people that you counted twice. In fact, if you look at this, there's 16 people you counted twice. Because if you add all of the A circle and all the B circle, you've added that twice. 68 minus 16 is only 52 people. So part B, you could have probably solved that quite easily just reading the question, 16 out of 100. You wouldn't have needed a Venn diagram. But in part C, find the probability a student at random does not do badminton but does archery. Well, there's 22 people in that section of that circle that are in the archery but not in the badminton. And so your probability would be 22 out of 100. And that number wouldn't have been easy just reading the question. Yes, I moved up. 120.
Huge.
That's crazy. Next definition. Yes. Yes. Didn't reduce that to 11 out of 50? I like 22 out of 100 because the context of the question, there was 100 students. So saying 22 out of 100 makes more sense in the context. You would get it right if you reduced it to 11 out of 50 as well. The union of events. Now, this symbol means or. And if I remembered that this symbol was and because it kind of looks like an A, this is terrible, but oops, this symbol, or, I don't know, it helps me remember, and an or. So it is where both are true. When you say A or B, right? If I ask you, are you a baby or are you in grade 12? The answer would have to be yes. You would want to, usually the human response is to go, I'm in grade 12, to tell the person that I'm answering yes because I'm in grade 12, not because I'm a baby, right? But if you had to answer yes or no, this is a court of law and it's like this, you're up on the stand and the question is yes or no, are you a baby or are you in grade 12? The answer is yes. You're one of those. Okay? And so when we draw the shading, you could have been a baby, the baby in grade 12, quite rare, or just the baby. Those are all possibilities. So find a probability the student does archery or badminton. We go back to our Venn diagram. There are 22 plus 16 plus 14, 52 people in total that do archery or badminton. Again, I didn't reduce this because we can see the answer out of the 100 students. This one is fairly straightforward. The key is, can you take the information, draw the Venn diagram, and fill in numbers in each of the sections? So here's our next question. A group of 30 students, 17 play computer games, 10 play board games, and 9 do neither. So when we draw our Venn diagram, or at least start to draw it here, there's the box representing all 30. 17 play computer games. That's a green circle. 10 play board games. Oh, the green circle I'm going to label as C for computer. The black circle here for board games. It could be that some play both, but it doesn't tell us. We have to use the information given in this question to fill in all the numbers. Are you okay with this being a 9 as the first number and the easiest number to fill in? Now you got some problem solving to do. Why? Because it says 9 do neither. So they can't be in either of those circles, but they're still part of the 30 students. What number can you fill in next, and why? Okay. So how did you, so you're saying, first of all, what's the number? 6? So he's saying 6 is in the middle, and the reasoning you figured it out was? So if you go 17 plus 10 plus 9, you get 36. And if I count the black circle, the green circle, and those outside, can you see that I've counted that middle section twice? And since we go over by 6, that gives us 36. Perfect. So you could have found the 6 first that way. I'm going to erase the 6. And I'm going to put a 4 in here. Let's say you didn't figure out the 6. How do I know this is 4? What's a logical way I could figure this out without figuring the 6 out first? Because if you figured out the 6, this would be easy to figure out 4 because there's 10 in total in board games. Yeah. So we're saying that the whole green circle is 17. Plus 9 here makes 26. How many more to get to 30? 4. In the same way, you could have done the whole black circle is 10 plus 9 is 19, meaning this one needs to be 11. We did already figure out the middle number was 6. Add them all up. Does it add up to 30 students? Yes. Then once you've got your Venn diagram set up, the probability questions become easy. What's the probability a person chooses board games? 10 out of 30. Plays computer games and board games? 6 out of 30. Plays board games but not computer games? 4 out of 30.